Alright, so in this video I want to go into the next section of the Rust programming book, and that is going over how functions work. I already have that open and I already created a new project, so let's get it. Move this to the side. Functions. Functions are pervasive in Rust code. You've already seen one of the most important functions in the language, the main function, which is the entry point of many programs. You've also seen the fn keyword, which allows you to declare new functions. Rust code uses snake case as a conventional style for function and variable names. In snake case, all letters are lowercase and underscores separate words. Here's a program that contains an example function definition. Alright, so let's write that one out just to see how everything works. Cancel. Alright, they left the hello world. They called another function, but let's define this other function first before we call it. Fn to define another function. Another function takes in 0 parameters, and it is only going to print something to screen. Another function. Now we have to call this in the main function, the one that's going to get ran, and we can compile it or run it. Cargo run. As you see here, we have hello world and another function. Alright. Function definitions in Rust start with fn and have a set of parentheses after the function name. The curly brackets tell the compiler where the function body begins and ends. Yes, we have that. We can call another function we've defined by entering its name followed by the set of parentheses. Yes, we did that here. Because another function is defined in the program, it can be called from inside the main function. Note that we defined another function after the main function in the source code. We could have declared it before as well. Rust doesn't care where you declare your functions, only that they are defined somewhere. Make sense? So let's move on to the next section. Functions can also be defined to have parameters, which are special variables that are part of the function signature. When a function has parameters, you can provide it with concrete values for those parameters. Technically, the concrete values are called arguments, but in casual conversation, people tend to use the word parameter and argument interchangeably for either the variables in the function definition or the concrete values passed in when you call them. So what they're trying to say here is that argument to parameter is going to be used interchangeably. What matters is we're going to be passing things into our function and we can define those. And then we have the example here, where now we're changing our code. So we want to be able to pass in a variable to another function. And we're going to define it as x, and we'll give it a type, I32. So sign integer 32. And we are now going to say the value of x is x, leave that alone. This is yelling at us now because this function takes in a parameter. So our editor is telling us this is wrong, which is nice. Pass in 5, we have the added information here. It's telling us that x equals 5. And we should be golden. The value of x is 5. Alright. Let's move on to the next example. When you want a function to have multiple parameters, separate the parameters declarations with commas like this. So now we're passing in 2 things in here. We're passing in an x and we're passing in a y, and y is going to have the same type. And now we're just printing this on a separate line. Print line, the value of y is and now this is yelling at us again because we are no longer satisfying the function. Takes in 2 params, we only pass it on. 6. So that's simple enough. You separate your param by commas. Function bodies contain statements and expressions. Function bodies are made up of a series of statements optionally ending in an expression. So far, we've only covered functions without an ending expression, but you have seen an expression as part of a statement. Because Rust is an expression-based language, this is an important distinction to understand. Other languages don't have the same distinctions. So let's look at what statements and expressions are and how their differences affect the bodies of functions. Okay, statements and expressions, figure out what the differences are and how they're to be used explicitly. We've actually already used statements and expressions. Statements are instructions that perform some action and do not return a value. Expressions evaluate to a resulting value. Let's look at some examples. So the example they give here, we no longer need another function. The example they give here is let y equal 6. Creating a variable and assigning a value to it with the let keyword is a statement. So let y equal 6 is a statement, right? Just as is defined here. Function definitions are also statements. The entire preceding example is a statement in itself. Statements do not return values. Therefore, you can't assign a let statement to another variable, as the following code tries to do. So here in this code, let's write it out real quick. Cancel. We're trying to say let x equal the result of let y equal 6. And for something like this to work, this expression or statement, not an expression, this statement would have to return something so that something can be defined to x. However, if it were to return something, then it would not be a statement, it will be an expression. And if we run it, we'll get an error. Let is a statement. Okay, moving on. Expressions evaluate to something and make up most of the rest of the code that you'll write in Rust. Consider a sample math operation such as 5 plus 6, which is an expression that evaluates to the value 11. Expressions can be part of statements in listing 3.1. I'm guessing that's this one. The 6 in the statement, let y equal 6. No, I am wrong. 3.1 is the previous one. Okay? The statement, y equals 6, is an expression that evaluates to the value 6. Calling a function to an expression. Calling a function is an expression. Calling a macro is an expression. The block that we use to create new scopes, this thing, is an expression. Okay? Let's see some examples for this. So right now they're saying that calling a function is an expression, i.e. calling a function returns something. Calling a macro is an expression. Macros are, they look like functions, but they have exclamation points after them. So like the print, this is a print macro right here. You see the exclamation point. But it returns something. It's an expression. And anything that uses these black scopes is an expression. Return something. And the example they have here is let x equal 5, which is a statement. let y equal, creating a new scope with these brackets, and this is going to return something. Let x equal 3, x plus 1. And we are going to use the macro and print the value of y. Which should be 4, right? Let's check it out. The value of y is 4. Now the reason it's 4 is x is 5 here. However, this is in this scope. In this inner scope, we define x to be 3. We do x plus 1, and because this is an expression, this last statement gets returned, and now y is equal to this last expression, or this last variable value, I should say. So y is then equal to 4. And that's what they state here. This is an expression. This block evaluates to 4. Note that x plus 1 line without a semicolon at the end, which is unlike most of your lines you've seen so far. Expressions do not include ending semicolons. If you add a semicolon to the end of an expression, you turn it into a statement, which will then not return a value. Keep this in mind as you explore functions, return values, and expressions next. So based on what they just said, if I put that there, I'm no longer returning anything. And as you see, when I put that there, this disappeared, the type of y. However, I remove it, we see that I'm returning something, and y is now a unsigned 32-bit integer. Okay, that's good to know. So the semicolon, if it is an expression, there is never a semicolon at the end. And expressions always return something. Okay? So now functions with return values. Functions can return values to the code that calls them. We don't name return values, but we do declare their type after an arrow. In Rust, the return value of a function is synonymous with the value of the final expression in the block of the body of the function, of a function. You can return early from a function by using the return keyword and specifying a value, but most functions return the last expression implicitly. Here's an example of a function that returns a value. Alright, so let's erase this real quick and start over, clean slate. And they created a function, fn, and they called it 5. It takes 0 parameters, but it's going to return an I32. And 5, which it has no semicolon at the end because it's an expression. And now our main is going to say let x equal 5 and then call it. As you see, we have our type annotation right there. And now we can print the value of x using the macro. The value of x is 5. There are no function calls, macros, or even let statements in the 5 function. There's nothing of that. It's just that. It's just the number 5 by itself. And that's a perfectly valid function in Rust. Note that a function's return type is specified too as I32. If you try running this code, the output should look something like bam, and we already did that. And here I believe they're saying that it's just the same. Running this code is the same as saying let x equal to 5. Alright, so let's look at the next one. Another example. we can erase this, and this example is going to be a +1. Given that it doesn't matter where we define our functions, I'm going to define it first. +1, right? And it's going to take a parameter x, which we're going to say is I32, and then we're going to return an I32. And it's just going to be x plus 1. However, they have a semicolon after it, so it is not an expression, thus it's not returning anything. I understand why they wrote that example, but since they already explained this pretty thoroughly, I'm just going to write it correctly. Main is let x equal +1, and we pass in our 5, and we have the print macro. Have an extra T. The value of x is the value of x is 6. Theirs has an error because they have this thing here, which now makes it a statement, and thus this function is not returning anything because statements do not return anything. And if that is the case, we get this error which says consider removing the semicolon. Remove it, run it again, x equals 6. That is the end of this section. Thank you for watching, and I hope that was helpful. Peace.